Hello everyone. In this video, we're going to talk about how we measure different variables. So we're going to talk about the different scales of measurement, nominal, ordinal, interval, ratio, also how to tell if a variable is discrete or continuous, and how do you choose a scale of measurement when doing research. And then finally, we're going to talk about Milgram's shock generator measurements, which is one of the questions in one of the activities. So very broadly, variables are just quantities that can change. So when you're measuring people's height, mood, hunger, weight, anxiety, depression, these are all things that are changeable. This is compared to a constant or something that doesn't change. So the reason the measurement of variables is important is how variables are measured determines which statistics we can use to analyze the data. So for every variable, you're going to have to identify the scale of measurement as nominal, ordinal, or interval ratio, and then also determine whether or not that measurement is discrete or continuous. So let's start with the nominal scale of measurement. This is the lowest level of measurement, where what you're doing is basically just categorizing things or people into groups, and there's no order to these groups. So one group isn't better than the other group. So this would be something like if we categorize people based on their major in school, right? Psychology, nursing, social work, and so forth. We could even assign numbers to those categories, say that psychology is a 1, nursing is a 2, social work is a 3, but those numbers don't indicate quantity in any way or quality. One major isn't better than the other, they're just different categories. Likewise, you could think about on campus or off campus, right? So you could assign numbers to those, like on campus could be 0, off campus could be 1, but those numbers don't indicate that one is higher or better or lower than the other. The next scale of measurement here is ordinal. So this is our next level, where now you're categorizing people or things into groups, but now those groups are in order based on how much of something they possess. So for example, like year in school, if we have freshman, sophomore, junior, and senior, we know that seniors are further along in terms of how many credits they've taken than juniors, but we don't know how many more credits, right? It could be that there's a 1 credit difference or a 2 credit or 10 credit difference between those two groups. Right? Likewise, between freshman and sophomore. We know that sophomores have completed more credits than freshmen, but we don't know how many more. Right? Similarly, you could look at grades in a class, A, B, C, D, right? Somebody who has an A did better than somebody who got a B, but we don't know how much better. It could be just a difference of like 1%. It could be the difference between like an 89 and a 90%, or it could be a much larger difference, like a difference between a 99% and 81%, right? We don't know, right? Likewise, like finishing place in a race. First place is better than second place, which is better than third, but we don't know how much of a difference there is between those groups, right? First place may have been a half a second faster than second place, or it might have been 3 minutes faster than second place. There's no way to know because the distance between those categories varies. Our next scale of measurement is interval ratio. So here we're again categorizing people or things into groups. Now, in this case though, the groups are in order and the intervals between the categories are equivalent in size. Now, there is a distinction between interval and ratio scales of measurement, where ratio scales have an absolute 0 point, whereas interval scales do not. So an absolute 0 point means the complete and utter absence of something. So like 0 degrees Kelvin would mean the complete and utter absence of heat, right? And we're not really that concerned with this distinction in this statistics course because all of the statistics you can use with interval data or ratio data you could use with each other. So there's no point in making this distinction right now, so we're not going to focus on this. So though when you're talking about interval ratio scales, this is where the numbers behave more like numbers than how you're used to talking about them, where the distance between any two categories is equivalent. So if I'm looking at how long it takes somebody to run a mile in seconds, the distance between 1 and 2 seconds is exactly the same as the distance between 31 and 32 seconds. 1 second always means 1 second. Those intervals are equivalent. Likewise, if we look at height in inches, right, the difference between 5'8" and 5'9" is 1 inch, which is the same as the difference between 6'1" and 6'2", which is also 1 inch. Where those categories are equivalent in size as you go along the scale. They don't change as you go. All right, things get a little bit complicated when you're looking at surveys or questionnaires. So when people ask survey questions, they do something like this, where they ask somebody to respond to this statement of, I like statistics. And people have to indicate how much they agree with that statement, where 1 is strongly disagree and 5 is strongly agree. And then typically there are a bunch of questions, and then people take the average response over all of those questions for an overall measure of how much somebody likes statistics. Now, there's some controversy about this, and some people argue that we should treat data like these as ordinal. However, the vast majority of researchers treat these data as interval, and so we're going to do the same thing in this course. When you see scales like this, you can treat them as interval for the purposes of this class. Now, in addition to knowing whether or not a variable is nominal, ordinal, or interval ratio, you also need to know if it's discrete or continuous. So a discrete variable just means that there are no possible outcomes between any two categories. Right? So for example, if I ask you how many children somebody has, they can't have a fraction, right? A fraction doesn't make sense. You have 1 child, 2 child, 3 child. You're not going to say 1.5. I realize people get into sort of mental gymnastics here, thinking about stepchildren and things like that. But you understand the principle here that you only have whole children. Right? In these cases, fractions and decimals don't make sense. So this is very often the case when you're counting things, right? The number of phones you have, the number of houses you have, right? Decimals and fractions don't make sense. And in this case, when you have discrete variables, when you're going to graph the data, you use bar graphs because you want to indicate that nothing exists between these two categories. So by a bar graph, I mean a graph where you have bars and the bars do not touch. Now, continuous variables are when you have an infinite number of possible outcomes between any two categories, right? Where here fraction and decimals do make sense, right? So we know that between 5 foot and 5'1", there are actually an infinite number of possible outcomes there. We don't really measure it that precisely, but fractions and decimals make sense when you're talking about height, right? So in those cases, we use a line graph or a histogram to emphasize that there's continuity between categories. And so if we do a histogram, it's like a bar graph, except the bars touch in those cases. Okay, so next, let's work through a few examples here. Let's start with some scales of measurement examples, starting with minutes to complete a math problem. So the question is, for the scale of measurement, is it nominal, ordinal, or interval ratio? In this case, it would be interval ratio, right? Because when you're looking at minutes, the categories of minutes are equivalent. The distance between 1 and 2 minutes is the same as the categories or distance between 3 and 4 minutes. A minute is always 60 seconds. It's always the same size. Okay, next we have preferred type of phone. You ask people what kind of phone they like. They can say Apple, Android, or other. So in this case, this is nominal data, right? So we have people are in categories. They're in either the Apple, Android, or other category, but there's no inherent order to those categories, right? One isn't better than the other. People are just expressing a preference and being put into one of those categories. Okay, next we have political party, Republican, Democrat, Independent, or other. So again, this is a nominal scale of measurement. We have people put into categories, but those categories are not in order, right? Even if we numbered them as a Republican 1, Democrat 2, Independent 3, and so forth, it doesn't imply an actual order. It's just using numbers as a substitute for a verbal label there. All right, next we have height, or not height, head circumference in centimeters. So head circumference in centimeters, we're looking at the centimeters there, and centimeters are interval ratio data because we're looking at categories that are equivalent across the span of the ruler, right? If you imagine a ruler, each centimeter is exactly the same size. There's no, the size of the intervals doesn't change across the scale or across the ruler. Okay, next we have high school class ranking. So we have like the top student, the first place student, second place, third place, and so forth. So we don't know how much of a difference there is in grade point average between the first person in the class, the second person graduating the class, and the third person, right? So because of that, that would be ordinal data. We don't know how much of a difference there is between each of those categories. Finally, we have socioeconomic status as low, middle, or upper class. So we have people put in order, low, middle, and upper class, but we don't know how much of a difference there is between people in any two categories. Right? We don't know how much of an income difference there is between low and middle class and upper class. All right, next we're going to look at some discrete and continuous examples. Okay? Starting with minutes to complete a math problem. In this case, do decimals make sense, right? Does a decimal or a fraction make sense? And minutes to complete a math problem, it does, right? There's an infinite number of possibilities between 1 minute and 2 minutes. Number of phones a person owns, that would be discrete, right? Because there is no possibility between 1 and 2 phones or between 2 and 3 phones. Only whole units make sense there. Head circumference in centimeters, that would be continuous, because again, decimals, fractions make sense. Number of multiple choice test questions answered correctly, you either get it right or wrong. So in this case, there are not, fractions do not make sense. There are no possibilities between, say, getting 5 right and 6 right, right? So that would be discrete. The number of baskets somebody made in a basketball game, right? You can't make a half of a basket, so only whole numbers make sense, and since fractions don't make sense, that would be a discrete variable. And then we have political party again, Republican, Democrat, Independent, or other. So we have categories here where there's nothing in between them. They're just distinct categories where obviously fractions don't make sense because they're not even numbers. So that would be discrete categories as well. So when you're looking at variables, you're going to determine if variables are measured on a nominal, ordinal, or interval ratio scale, and also whether or not they're continuous or discrete. So in general, if a variable is nominal or ordinal, it's always going to be discrete. Interval ratio variables can be discrete or continuous. It will just depend on the variable. So the examples you're going to be working with in class, you don't really get to choose how you're going to measure variables. But after you take this class, you may very well have the opportunity to decide to measure some variables. And given the choice, always try to measure variables using more precise measurement methods. Like try to use an interval scale of measurement rather than nominal or ordinal. Likewise, if you have a choice, don't ask people yes/no questions, but try to ask them questions on more of a continuum. Not do you like statistics, yes or no, but it could be how much do you like statistics. So the more variability you have in possible answers and the more precise your measures are, the more statistical options you have. Right? So for example, if you think about this, how would you ask if someone is right-handed or left-handed? So here are 2 examples of ways you might ask about handedness, right? You could ask people, are you primarily right-handed or left-handed? And they would just respond with right or left. Or you could ask them to do a scale like below, where you ask them to indicate your preference for using your right or left hand when throwing a ball, where they would indicate on a scale from 1 to 8 how much they would prefer their left hand or their right hand. This second measure would give you a lot more variability in measures and more precise measures to use for your later analysis and would give you more options. So one popular way that researchers use to measure handedness is the Edinburgh Handedness inventory. So here they ask a series of questions about which hand you prefer to use when writing, throwing, using scissors, and so forth. So if you're interested, there's a link there so you could go try it out online for yourself. So that should be enough to get you started on the activities in Chapter 1, where you're looking at the different scales of measurement and discrete continuous variables. Good luck.